Hello everyone, welcome back again. Last video was about finding out the vector equation of a line. So continuing with that topic, let us solve a couple of questions based on finding out the vector equation of a line under given conditions. So first question is, this is illustration 15 of overall chapter. So the coordinates of A and B are -2, 4 and 1 and 2, 1 and 3 respectively. We have to find out the vector equation of a line AB, right? So suppose again, if you can imagine the diagram that I have told you in the last class, that there is a point A, there is a point B, and if you are able to find out or draw the triangle OAB and apply the vector law of addition, you will get to know that how to find out the vector equation of a line. If you have understood that the vector equation of a line is basically based on triangular law of addition, right? So we have been given 2 points whose position vectors are -2, 4 and 1 and 2, 1 and 3. So this is a point A and this is a point B, for example, and this is O. Okay, let us join these 2 points. Fine, so this is your OA, this is your OB, and this is vector AB, right? So it is -2, 4 and 1, and this is 2, 1 and 3, right? So what this vector equation says, that vector R is equal to OA plus lambda times AB, right? We know the value of OA. Vector OA is -2, 4 and 1. I can use the column vector plus lambda times AB. So what is AB? AB is actually OB minus OA. I can write this as OA plus lambda times A vector. AB vector is OB minus OA, subtracting the A position vector from OB, right? So if I subtract A from B, I will get 2 minus -2 is 4, and 1 minus 4 is -3, and 3 minus 1 is 2. Okay, this is your vector R. Fine, so this is your first part. Second, it says that does the point 6, -2 and 7 lie on the line AB? So there is a point P on the line AB. This we have to find out whether this point P is lying on this straight line or on this vector AB. That means for some value of lambda, if P is lying on line AB, if P is lying on this line, right, that means for some lambda, all the 3 coordinates of x, y, and z must satisfy. Meaning is, yes. So we are assuming that this point is lying on the line AB, and if this point is lying, that means the coordinates of the LHS and RHS must satisfy, right? So for this point P, we have the position vector P. So in place of vector R, I will write this position vector as P, right? So this means that 6, -2 and 7, this is the position vector of this point P, right? As you can see in the diagram, I can call this as vector R. So I know the value of vector R, which is 6, -2 and 7, assuming that it is lying on the line AB, remember, right? So this is equal to AB, which is -2, 4, not AB, this is OA plus lambda times AB. So this is 4, -3 and 2, right? So coordinates on left hand side must be equal to the coordinates on the right hand side if this point P is lying on the vector equation line, right, on this straight line. It is simply like if we have an in Cartesian system, if we have x plus 2y is equal to 3, for example, and it is asking you that find out whether the point 1, 1 is lying on the straight line, right? So what we did is that in place of x, we put the value of x as 1, and in y, we put y also 1 if the coordinate is 1, 1, right? So if this is 3, this is 3, right? LHS is coming out to be 3 and it is equal to RHS, then we say that 1, 1 is lying on this straight line, right? So same thing we are doing in vector form, that this, if it is lying on the line AB on this straight line, then the position vector must satisfy this condition for some value of lambda, right? That means if I equate this, minus 6 minus 2 and 7, this is equal to, if I rearrange the x, y and z components, means I, j and k components, so you will get minus 2 plus 4 lambda, this is 4 minus 3 lambda, and lastly is 1 plus 2 times lambda. Okay, so both all the three coordinates must be equal. So it means from first, if I equate the x coordinate on LHS and RHS, I will get 6 is equal to minus 2 plus 4 lambda. And from here, I get the value of lambda as 2. Right? Meaning that for this same lambda equal to 2, y and z component must also be equal. Right? So putting in the second equation means equating the y coordinate, which is minus 2 is equal to 4 minus 3 lambda. This lambda should satisfy this equation. So if I put lambda is equal to 2, I will get 4 minus 6 is minus 2. That means minus 2 is equal to minus 2. It is satisfying the y coordinate. Let us check for the z coordinate. LHS it is 7, and 1 plus 2 lambda is 7 is equal to 1 plus 4. Putting lambda equal to 2 here, right? This is 4 plus 1 is 5. That means 7 is not equal to 5. So we say that z coordinate is not satisfied. Right? So if you are able to find out a single coordinate, not all the three coordinates, but at least one coordinate you are able to find out which is not matching, right? Then we say that the point P, which was 6, minus 2 and 7, it is not lying on the equation found in part 1. Okay. Now third part says the point N lies on the line AB. Right now it is given that N is lying on AB. That means for some lambda all the three coordinates x, y and z must be equal. And it is given that 3 times an is equal to nb, we have to find out the coordinates of n. Right? So let us again sketch this curve. This is your OA. This is AB and this is OA. O, A and B, and it says that there is a point N along AB vector. There is a point N along AB vector such that 3 times AN is NB. Okay, let me write here. This is your third. 3 times AN magnitude is equal to AB magnitude. Meaning of this is that N is lying somewhere along the line AB such that thrice of that magnitude, the distance of the point N from A, right, is equal to AB, or AB distance is thrice of AN, right? That means N will lie towards A. N is lying towards A, right? So if this is 1, right, so this will be 4. AB is thrice of AN, not 4. AN thrice of AN is AB. Yes, so this is 3, sorry. Is it AB or NB? Let me check. NB, sorry. Yes, that's what I thought. So this is NB, not AB. Now it is clear. So it says that the distance of NB vector is thrice the distance of AN vector. So this I will call this as 1 unit, and the distance from N to B is 3 units, right? And we do not know the vector AN and we do not know the vector NB, right? So I will write this AN in terms of AB vector because I know the vector AB using the position vector of A and B, right? That means thrice of AN magnitude, not thrice, so if I write AN vector, so it will be 1 by 4 of AB, right? Total parts of AB will be 4. So in terms of AB, I will write vector AN. Why I am doing this? Because again, if I have to find out the coordinates of this point n, that means this n should satisfy the vector equation of line AB, right? That means I have to find out the position vector of ON. Okay, this vector we have to find out. Finding out the coordinates means finding out the position vector of point n such that n is lying along line AB, right? With the distance that this unit is 1 and this distance is 3 units. So in terms of AB, AN is 1 by 4. Now applying the vector equation, again it will be that the position vector of ON will be vector R is equal to OA plus AN, right? In this triangle OA and N, in this triangle, applying the triangle law of addition, OA plus AN is ON, right? And now writing AN in terms of AB, it is OA plus 1 by 4 of AB, right? So OA vector is minus 2, 4 and 1, minus 2, 4 and 1 plus 1 by 4 of AB. Meaning is that in the first question, in the first part, we have find out the value of lambda, which is 1 by 4 in case of this n. Means n is lying on line AB such that this lambda becomes 1 by 4. Right? So AB vector is 4 minus 3 and 2. This is 4 minus 3 and 2. Right? So it is minus 2 plus 1. This is 4 minus 3 by 4. And this is 1 plus half. Okay. So coordinates of n are minus 1, 13 by 4 and 3 by 2. Okay. This is your answer. Right. Let us do next question, which is just like that, but things will become more clear to you. So illustration 16 says that there are the coordinates of 3 points A, B and C like this. We have to find out the vector equation of the line AB, right? Again, we can write this as vector R is equal to OA plus lambda times AB. So vector OA is minus 1, minus 2 and 1 plus lambda times AB. AB is subtracting A from B. So minus 3 minus minus 1 is minus 2. 4 minus minus 2 is 6. And minus 5 minus 1 is minus 6. Right? So this is your answer number 1. Fine. Then we have to find out the coordinates of the midpoint M of AB. Right? So I think the diagram will help you. Again, the same diagram. This is O, this is A, this is B, and there is a M, which is the midpoint of AB. So if M is the midpoint of AB, that means this is 1 and this is 1. Right? That means whole vector AB is divided into 2 equal parts. Right? So I have to find out the coordinate of M, means the position vector of M I have to find out. So let that position vector is vector R. So this is OA plus, so this distance is 1, that means in terms of AB I can write AM, this lambda times AM I have to find out. Okay, so that means this is OA, let me write the vector minus 1, minus 2 and 1 plus this is half of AB. Okay, AM vector is half of AB. That means minus 1, minus 2 and 1 plus half of AB means half of minus 2, 6 and minus 6. So it is minus 1, minus 2, 1 plus minus 1, 3 and minus 3. So finally, the coordinates of midpoints are vector R is equal to minus 2 plus 1 and minus 2. Right? So you can write coordinates of M as -2, 1 and -2. Okay, -2, 1 and -2. So this is your second part. Now third part is the point N lies on BC, right? So there is a point C also in the space, right? So let us write this point C somewhere here. Okay, so let us say that this is your point C, right? And on this BC, the point N is lying, right? So let us join this B with C, and there is a point N, right? So position vector of N is such that the twice of Bn is equal to Nc. So this time Nc is twice of Bn, means distance of Nc is twice of Bn. So N will be lying towards N. Why? Because this Nc is twice of Bn. This point is B. This point is B. Okay. So let us join this. Let me use another color. This is your On, like this. Okay. This we have to find out. Find the equation of line Mn. Okay. This line Mn equation we have to find out. Meaning I have to find out the vector equation of line Mn. So as you can see here, if you look closely, that Mn means I have to go from M to B and then B to N, right? Meaning position vector of this Mn or vector equation of line Mn means just like I have expressed the vector equation of line AB, right, using the triangular law of addition. So for this small triangle, this triangle MBN, right, on this small triangle I have to apply the law of addition. OM plus lambda times Mn will be On. All right. Okay. Let me draw this figure again. Something using bigger sides. This is your OM, then MB and BN, then MN. MB, MN, and this is your MN. Okay. And this is your O, and joining this O with N like this. Okay. So Mn we have to find out. Mn means OM plus lambda times Mn is equal to On. This is the vector equation, right? So third part is OM vector R is equal to OM plus lambda times Mn will be the vector equation. Now M is the midpoint. We know the coordinates of M, which are -2, 1 and 2. So I know the vector OM, right? I have to find out vector Mn, right? This vector Mn I have to find out, and I also know the vector Mn will be MB plus Bn is equal to Mn, right? And this is point C, if you know, such that this is 1 and this is 2. Okay, so in triangle, I will say that in triangle MBN, MB, vector MB plus vector Bn is equal to vector Mn, right? Vector MB plus Bn is equal to Mn. Okay, triangular law again. Now MB means this was the midpoint. So whatever is the, I would say, the direction of this Mn, MB I will write as OB minus OM. This is MB. Position vector of OM will be subtracted from OB, right? Plus Bn will be, what is this Bn? Bn will be 1/3 of BC. If you see the original diagram, this BC was a straight line. So N was 1/3 of BC, right? So Bn is 1/3 of BC. This is your vector Mn. Okay, now BC, Mn I can find out because not Mn. This OB, I know the position vector of B, which is -3, 4 and -5. -3, 4, -5. I know the position vector of M, which is -2, 1 and -2. Right, plus 1/3 of BC. So BC vector is OC minus OB. OC minus OB means from C I have to subtract vector B. So 0 minus -3 is +3. This is -6 and this is 9. Right, 3 minus 6 and 9. This is 3 minus 6 and 9. Okay, I know the question becomes too long, but that's how you will learn. Okay, so just stay with me. Right, so basically I am just repeating the concept. What we have to find out is the vector equation of line Mn, which is Om plus lambda times Mn will be equal to On. Yes, Om plus lambda times, yes. Right, so this is the position direction. You would say that Om will be the location vector and Mn will be the direction vector. So that will give you the equation of line Mn. Right, now I have to find out Om. So Om we already know. This is the position vector of M, which is -2, 1 and 2. And Mn, in order to find out Mn, I have to find Mb and Bn. So Mb plus Bn will give you Mn. So in applying triangular law of addition here, I have written Mb plus Bn is equal to Mn. Right, now Mb is OB minus On. So this is your Mb plus 1/3 of BC, which is C minus B. Right, this is your vector Mn. So let us quickly calculate this. Minus minus will become plus, so it is -1. -3 plus 1 is -1. 4 minus 1 is 3. And this is -5 plus 2 is -3. Right, this is plus 1/3 of this will be 1, -2 and 3. Okay, this is your vector Mn. So vector Mn is 0, plus 1 and 0. Right, now Mn you have find out, Om you already knew. So my equation R is Om plus lambda times Mn. So Om was -2, 1 and -2 plus lambda times 0, 1 and 0. This is your required vector equation. Okay, that's all. So like this, you will get some questions on finding out the vector equation. So do not hesitate. If there are multiple parts or if there is so much information, just remember this, that triangular law of addition is the basis of finding out the vector equation of a line. And just simply write down what finally you have to find out, and then just calculate using the given information that if I have to find out MB, then how can I use the given information using the position vector of B and M, I can find out MB. Similarly, I can find out Bn using the triangular law of addition. Okay, so I think that's all for finding out the vector equation. That's all for today. I hope you enjoyed the video. See you soon. Thank you.